Hello everyone. We'll be soon starting with today's presentations for the HyperApp Digital Alpha event. So, first team which will be presenting on today is Team 5. I hope the members presenting today for Team 5 are present here as attendees. I kindly request all of the attendees to raise their hands so as to I can make them presenters. Just before starting, I would like to tell everyone the flow of today's event is 15 minutes for presentations, followed by 10 minutes for question and answer. Um, like at 13 minutes, all the presenters will be given a buzzer as a warning. And as you have all informed, there will be penalty for extra time if your time exceeds the given PPT time. So yes, I'll just inform you, and then we can start. Yes, the team can present their screens now. Yes, the team can now begin their presentation.
Hey everyone, have you ever wished for analytics to be super easy? We did too. And today, with Sassify, we hope that the dream comes true. Before we deep dive into the product, it is essential to understand the need for a SaaS analyzer. So here we go. SaaS companies are hot investment targets at the moment, with their index outperforming the market by over 800%. Also, their returns being over 250% in the pandemic, and their valuation to revenue multiples growing 2x in 3 quarters of 2021 itself. Why this magnanimous growth? This is because this is a recurring revenue business, meaning that subscriptions of the same product with minor changes can serve multiple clients. Also, by the nature of software business, not a lot of upfront investment is required, making it a high margin business. So, SaaS is fast growing and has a peculiar nature. But then, why can't we use traditional metrics and tools to analyze this industry? Well, this is because SaaS companies have digital assets instead of physical assets that can be represented on balance sheets. Also, their heavy subscription centered business models call for fresh metrics focused on different points in the customer funnel. Right. So we've established that SaaS companies need custom metrics, but we can't use company reports directly because metrics are buried somewhere in the text, which are hard to locate. To make it absolutely clear, SEC filings are wordy. We have seen 10Ks with over 250 pages of text. They are inconsistent when it comes to it because anything can be present anywhere under varied names. Also, comparing two companies or exporting data for analysis is inconvenient in a report format.
But we may not be our ideal customer profile. Let's see how Christy, a top tier Wall Street analyst, feels like. Christy is often frustrated as she has to read multiple reports to find conclusions. She can't plug all this data easily in her existing models. She has to use multiple tools like Bloomberg, other screeners to monitor companies, and Power BI to plot these metrics. But what she really wants is to build an optimal portfolio by finding the right metrics of a hot sector like SaaS. This is where Sassify aims to make her and your life easier. Sassify is a one-stop solution for visualizing, analyzing, and notifying users about any possible information from a SEC filing. Out of the ecosystem of 290 companies, any tool can help you remove the penny stocks and arrive at 240 growing companies. But every tool starts failing in further narrowing down due to the intrinsically different set of metrics for SaaS. With Sassify, we monitor more than 40 plus KPIs on 10 million rows of financial data, thus helping Christie create an optimal portfolio of 40 companies. Let's dive right in. This is a product overview of how our key features look like, which we will evaluate further. Our product is dashboard first with three key offerings. First, a company specific dashboard. Second, competitor benchmarking. Third and final is the calendar and update section. We have seven further tabs in the company specific section, helping you analyze both quantitative and qualitative data of a company. This is how the company specific dashboard looks like. User can track the daily share price of a company. We also provide a buy or sell signal sourced directly from the Nasdaq API. Then we want users to analyze all the key metrics directly through our KPI cards. As you can see, we compute ARR by customer and EV by revenue multiple for Alteryx. We also tell them which percentile a particular company lies in. Then we report crucial metrics which a user shouldn't miss. Here, the ARR has been reported. On hovering, you can see the value, source, confidence score, and the date of the filing. As these are NLP models which we are using, our confidence helps cement a user's trust. And you can search for the source in the filing. Finally, with our date filters, you can narrow down your search for the share price and the metrics. We extract financial statements right from the SEC filing, thereby adding a layer of trust for the user for all three documents. Next is the closing share price versus filing date comparison, which allows one to understand how investors react to the release of any filing. Users can monitor the date. Here, a sharp price drift is visible around 4th of August. Hence, we apply a filter to find a price drop of more than 45% after a 8Q notification was released, which signifies bad news. After this, we have the ownership data sourced directly from Yahoo Finance, be it the top mutual fund holders or the top institutional holders. But given all of these features, the icing on the top would be the metrics section. These are all the metrics for Adobe. You can see their source on hovering over the graphs. You can apply filters according to the goals with which you want to see all of these metrics. So let's say I want to only analyze the financial goals. I can deselect all the other options. I can go to gross margin. I can check its formula and I can see how it has been varying over the years. We also give the users an option to download all the data in CSV with columns highlighting source and confidence. Final leg of our dashboard analyzes the text heavy part. This is the heat map which analyzes the word frequencies of management discussion and analysis section with top words sorted at the top. As you can see, there has been a spike in debts count from the year 2019 onwards, which basically signals how debt has become a focus for the management in the yesteryears. Next, we analyze the sentiment of items 7, 8, and 9. But most of these sentences have neutral polarity. Our model helps you identify what matters. We give you the sentiment count of each particular item. Then, by viewing sentiment, you can see a summary of the top positive sentiments and top negative sentiments. Let's take one example how our model performs here. Here you can see how Alteryx management's cultivation of relationship has been signified correctly by our model as a positive sentiment. Lastly, uncertainty and risk are fundamentally linked to all of these companies, which you should know about. Our model benchmarks them across 5 different risk categories. Any major spike in these graphs will show you a red flag for all of these companies in a graph. Our computer benchmarking helps you analyze not just two, but any number of companies. Let's see how Alteryx stack against MongoDB or Datadog. In our benchmarking section, we perform risk analysis on 5 different risk categories through a scatter plot. You can compare multiple metrics which we reported for a company by historically stacking all of these bar graphs on any metric. You can apply a filter to narrow down the date range for all of these metrics which we have computed. Again, we give you an option to download all of this data through a spreadsheet format in a single click. Finally, any number of features we create. Nobody wants to be glued to a screen all day. Our calendar update allows for automatic notification for all companies right after we get a new filing. Just subscribe to all of these alerts and you are good to go. Now we have analyzed a lot of features, but let's understand what goes behind the scenes with our engine to make all of this happen.
To incorporate the wide range of features, we faced multiple challenges, stacked under these 4 broad headings. Though we went ahead with building a dashboard with just last 5 years of data, there were around 8,000 filings on which NLP algorithms were to be applied efficiently. To facilitate the financial and investment decisions, achieving a high accuracy on the metric extraction was an important focus for us. Now, whether it's a 10K filing or a 10Q filing, there are 3 rich sources for metrics, that is, form tables, text, and the XBRL tags. These 3, being independent in nature, are pre-processed separately and are stored for different use cases. For text, we take advantage of a filing being pre-divided into defined items. One of the most diversified challenge was to figure out a way to extract the metrics buried deep inside the text. Why diverse? Simply because a human can write a same sentence in multiple complex ways. In upcoming slides, I'll walk you through how we approach this problem and how we build a robust, accurate solution. Let's start with a very simple example. ARR for fiscal year 2021 was $312 million. At the very first sight, this appears a simple problem to map metric value and date. This is done using named entity recognition. But as we move forward with a slightly complex problem, as shown here, the basic logic fails. Mapping two dates with two values is the next problem here. This can also be achieved using dependency parsing. We construct a tree using the dependencies, and we map the corresponding money 1 with date 0 and money 2 with date 3. If we increase the complexity even further, here we can see there are four values: 7%, 5%, 300 million, and 500K, to be mapped with two metrics for two different years. For such cases, the dependency graph becomes more compound and it fails to identify the relationships. So, what we need is a language model to understand the context of the sentence before providing the predictions. Question answering is a strong NLP approach where, provided a passage and a question, what we get is the start and end position of the answer. But it has some drawbacks too. High chances are that the prediction can contain some peripheral garbage values. So, summing up, NER helped us in extracting the exact metric, date, and value tags, and question answering helps us in understanding the context of the sentence. We combine these both approaches and we ask our model three different questions. To pick a perfect match of all the combinations, we do a grid search on all possibilities and we pick the one with highest confidence score. But why are we asking three questions instead of a single question like, what was the ARR for last year? The answer is to have a high confidence while predicting the output. It is important to understand here that why we are achieving high confidence. It is because the model validates the context understanding for the matching combinations. Additionally, we also store the sentence and we display the confidence score to the user to justify our extraction process. But now, as we get the accurate combinations, another challenge remains to map the phrases like this year, or last quarter to the exact dates for comparison. An intuitive and a strong logic is used to map these date tags to the corresponding year using filing date as a reference and cosine similarity. As you can see, last year and previous year will have highest similarity. Similar logic is used to map numbers using regular expressions and Python libraries. For sentiment analysis related tasks, instead of relying on a single model, we take an ensemble voting or four different models. In this slide, we compare our in-house NLP algorithms with paid available APIs like AWS Comprehend and GPT-3, which will cost you around $1 to $2 per filing. Performance benchmarking is done using 200 annotated sentences from 10K filings, where our approach outperforms the paid APIs. We also submitted this benchmark data during our code submission. Now, to reduce toil while running the same complex pipeline again and again, let's go through our scalable and automation infrastructure.
Continuing with the challenges faced while designing the system, our next task was to design a low latency system capable of handling huge volumes of data. We also wanted to automate our metrics extraction pipeline. Suppose a new filing arrives. We don't want to apply each individual pipeline manually. So automating the entire parsing and extraction process was another add-on challenge to keep our product updated with the latest metrics. An additional challenge was to notify the users about new filings and metrics which are updated in the dashboard. Finally, we wanted to achieve these above goals in a cost and compute effective manner. In the next slide, we describe the different modules used in our system. The first module is the AWS Lambda, which is a serverless, event-driven compute service which triggers the text, XBRL, and table extraction pipelines. The Edgar Scraper environment implements our metrics extraction pipelines and stores the extracted metrics into our scalable AWS database. Backend is then implemented in the form of a Django REST framework, which communicates with our front end through REST APIs. Taking a deeper dive into the intricacies of a system, we see that the Lambda is triggered every day at 6 a.m. UTC, after which it wakes up the Edgar Scraper environment. And finally, after the metrics extraction process is completed, it notifies the subscribers about all new filings by publishing to the AWS SNS topic. When the Edgar Scraper environment is switched on, it subsequently checks for new filings of a company and examines whether they are added to our database. If not, it runs our three-dimensional pipeline and it stores the extracted metrics into our PostgreSQL database. Our modular design allows our backend to be scalable to many systems as the scope of the project increases in the future.
Let's take a quick pause here so that we can view a summary of our features and what problems they solve. On the next slide, we want to depict how our technology also takes care of all the technical challenges. We have a plan in mind for what we lack and where we want to proceed next. The next slide depicts the integrations that we have planned for the future. Next, we are looking at a host of improvements to make our extraction module more accurate and more scalable. We also want to include additional features like company subsectors, management analysis, and insider trading stats. We do understand that even the existing features can be improved. Currently, our dashboards are not personalized, and benchmarking section does not provide a list of direct competitors, both of which we intend to fix in the future. We can target an even higher confidence score for the extraction, for which we intend to ramp up our model. Another solution for the same could have been to directly scrape the metrics from third-party paid APIs like BAMSEC or the SEC API and publish them on our web tool. But we believe that building an NLP model from scratch was the essence of the problem statement, so we did not venture there. Thanks for hearing us out. Any questions now would be welcome.
Thanks for the great presentation, everyone. So quick question, like from what you presented here and what's in the GitHub, like is everything that you presented there in the GitHub, like the code that we looked at?
Yes, sir. Every NLP pipeline and the backend code and the front-end code and the automation pipeline is present inside the GitHub.
Okay. If you can go back to the where you showed the data, like the tabular form of the data, there were certain gaps in certain metrics, right? How did you deal with those gaps, especially if you have to present a historical chart of those numbers, or if you have to run models on those numbers? How did you deal with the gaps?
Sir, the gaps are present only for the text-based metrics. For the metrics which are derived from XBRL taxonomy, we don't have much gaps there. But the thing is, XBRL taxonomy also changes with time. The slide that you are seeing on the screen shows on how many companies we successfully parsed the data from XBRL, and for how many it was failed, and for how much it was unavailable.
Okay, so how did, like, in cases where you were not able to parse, what are the reasons why? I see ambiguous filing structures, XBRL taxonomy changes with time. So from design point of view, like let's say, for example, we have to handle these changes in XBRL taxonomy, and we want to basically get them for last 10 years. Like what is your finding and suggestion in terms of how to handle those things?
Okay, sure, sir. So for we went with last 5 years. So initially, what we noticed is much of these cases the XBRL taxonomy changes and it fails. But the problem is we found the one thing that you are seeing on the screen, like the value was first written in the string format and then it was written as the final integer format. So these are some of the minor changes, minor tweaks, because of which the code fails again and again. So this was done using analysis. Like what we did is, why is our code failing for most of the cases? So we analyzed the code, we analyzed the XBRL filing for that particular company, and we fixed our code. Now, in our case, our code can handle properly. It can perfectly extract all the XBRL tags for the last 10 years. The problem is, like, even though the XBRL taxonomy changes, there are some companies that follows the same old taxonomy. So that is where some exceptions occurs. Apart from that, our code can handle the changes in XBRL taxonomies.
Okay, but you are managing that. Let's say, for example, in cases where like companies are still filing in the old format, are you managing, like, from design point of view, how are you managing that in your design, like at a
Yeah,
company
so
level?
okay. So I'll go into some more detail. So for XBRL tags, we are getting 3 files. From the 3 files, we are generating a mapping. Okay, so what happens is, for some cases, the value was written in this case, like in a string format, and what we are getting is again a decimal point, like into 10 to the power 5 or into 10 to the power 6. In some cases, it was already multiplied. In some cases, it was not. So what we are doing is, but there was a small difference, like the tag name was different in both the cases. So by using such observations, what we derived two approach. Like if the tag name is this, then it is for sure that this is a old taxonomy.
Okay, and for the metrics that are that appear in the textual section of the filings, if the naming is not consistent, let's say for example customer acquisition cost, right, it can appear in different flavors. How did you normalize that nomenclature where different
Yes.
companies could be using different keywords or metric names?
Yes. Okay. Yeah, so for such cases, so in our code, you will find a mapping, you'll find a JSON file called metrics.json. It contains all the mappings, all the different type of mappings that are possible. The source for that mapping is also presented in our report. In our report, there is a link to the Notion doc, which leads you to the all different forms of formats that different company uses. So by using that metric.json, what we do is, so like ARR can be presented in some, say 3 to 4 different ways. So what we do is we search for that term, we tag that using our process, and we link that to ARR. So in the entire dashboard, you will see ARR, but it might be reported as annualized recurring revenue in some filings. But we have that mapping, which we have created by analyzing, and we use that.
Adding to what my teammate said, we have developed an extensive hierarchy of all of these metrics. So let's say there is a metric like dollar-based net retention, which is being reported by companies. So on analyzing all of these filings, we understood that there is a list of more than 25 to 30 different variations, which is being computed by the companies. It can be told as net revenue retention rate. It can be told as dollar-based expansion rate. It can be told as retention rate. So we compiled all of these different filings. We created a hierarchical structure on what the base metrics look like and how we can create derived metrics on the top of these base metrics. So let's say dollar-based net retention rate was a function of gross margin, annualized recurring revenue, total number of customers we have. So using all of this and NDR, we were able to create a hierarchical structure. So all of the metrics which are being computed have been properly documented in our report structure as well, where we tell like these are the base metrics which we are using and what are the different nomenclatures, different mappings, different versions of the names. And then we finally how we compute them on our dashboard along with a confidence score for text-based metrics, because we also know these are presented using NLP models and there is a certain confidence score which we should present to the user so that they also understand. For XBRL taggings and for the metrics which we are getting on a daily basis, like share price, IPO multiple, we have a 100% confidence score for those metrics.
Yeah, how does that confidence score work? Like what kind of algorithm goes into coming up with the confidence score? Can you give some examples?
Like for XBRL tags, we are sure that it comes from the taxonomy. So we are
Yeah,
sure that the
not
tag is correct.
XBRL,
For the
but the metric, the text
yeah,
metric.
okay, yeah. For the text-based metric, I have explained the pipeline. Like we first ask our model 3 different questions, and on the basis of the answer, so question answering model provides you with a confidence score, like how confident it is by while predicting the answer. It depends on multiple things, like how complex the sentence is and how what is the question. So on basis of that, we decide that what is the confidence score. The confidence score is provided by the question answering model.
Okay, and what are the different Q&A models that you tried before narrowing down on the one that you're using right now? And how do those how does the benchmarks compare?
So initially, what we did is we started with some simple examples, and and with the simple examples, we tried TAT QA, table QA, and after that, we went with the Robata-based models. So finally, we are using Robata-based models. Like the TAT QA model and FinQA models, they were quite heavy models, and because of which, so now we went ahead with Robata-based models. What we believe is the Robota-based model is trained on a very huge amount of data, and it can be fine-tuned with some SEC filings data. And if that can be done, then a confidence score may further improve.
Okay, right now, like what are some of the metrics for which it failed, the Q&A, some of the cases for which it failed?
Okay, can we go to the slide, please?
Can we go to the question answer slide? In fact, we have this question in our question answer slide.
Yes.
To get started with the answer, to give you an example, the model fails where a human may also fail. So, for example, if a company has written that, let's say, the net dollar retention can be in the range of 114 to 118%. In those cases, the model fails. This is an example of a case where the model fails.
Okay. And I see the first question here. Can you also like dive deep into why the NER is used twice, like in extracting the numbers from the text for the for the metrics that are buried in the text?
Hmm.
Can you go through that pipeline in deep?
Sure,
How
sir.
the combination of NER and Q&A is working
Okay.
together, and how and why you're running the NER twice?
Yes. So, yeah. So, given a sentence, what we first want is to extract all the possible tags. By tag, what I mean is all possible metric, all possible dates, and all possible values. Once we extract all these tags, this is done using NER. Once we extract this tag, we ask our model three different types of questions, as I mentioned earlier. Now, using these three questions, we get some answer. Again, question answering model is a language model which provides you with a start and end position. It can contain some garbage values. So, but we believe that answer can be there inside that start and end position. So we again apply NER there to get the exact answer. The reason we are applying NER is because ultimately these all are values which will be stored in the database, which should be in a form of integer or a float value. We can't store text directly. We can't just trust on the QA model, which is just providing us with start and end position. We can't take that and put in our DB. So that is why we apply NER twice to make sure and to get a final integer or a float value.
Okay. And what does your database look like?
I
Your
think
data.
a backend team can take this up. Am I audible? I think our backend team can take this up. How a database looks like.
Sir,
Yes.
okay, my colleague can go ahead. Sir, we have basically two different types of metrics. There is a base metric table, which stores the metrics values along with the some peripheral data regarding the data, such as the source of the metric, the start date and the end date of the metric, and along with, if it's a text-based metrics, the actual sentence from which it was derived. So this is gives us the exact schema of the database, after which we query our database to display the data values in our dashboard.
And do you store things such as confidence scores as well, right, for each of these metrics? Or
Sure, sir, in case of text-based metrics.
okay, cool. I'll
Yes, we store all of these metrics. So, yeah.
okay. I'll pause and see if any of the other panelists have any questions.
Yeah. So it's been the Q&A time is over. So if like any other judges have any other questions, so they can wrap up fast.
I think I'm good. Rajesh, you covered.
Okay, cool.
Okay. Yeah. Team five can stop presenting now, and I'll remove the presenters from stage. Yeah. So we can move forward, right?
Yes, we
So
can.
next, yeah. So next we have team three coming up. So whoever are presenting today for team three can kindly raise their hands. Team 3, are there any other members coming in, presenting? Team 3?
No, that's all.
Okay. So currently we have 3 presenters on the stage who can present their solutions. So yeah, so you can now present your screens and I'll inform you when you can start beginning your presentation.
Mic off for you.
Yeah, I hope the team is ready for presenting. So yeah, you can kindly begin your presentation.
So am I audible?
There is an echo from your side. Can you please check your mic?
Yeah, just a second.
Yeah, I think now it's fine.
Just a minute. Sorry. Okay, so I will start. Good evening, everyone. We are Team 3 and we will be presenting our product sec filing analyzer for SaaS companies. So let's start with understanding the problem statement. Hello, am I audible?
Yes, you are.
Sorry for the disturbance. Okay, so I'll be starting with understanding the problem statement. So the problem statement is majorly divided into three segments. So first one is gathering that data from SEC filings, and the data is huge, and then analyzing this data using machine learning and deep learning techniques, and then finally showcasing these analytics on a user-friendly web-based application. Now let's talk about data, the core of the application. So we had 300 companies, and each of these companies have three type of forms: 10K forms that are yearly reports, 10Q that are quarterly reports, and 8K with no specific time periods. So these reports are majorly textual, ranging from 10K to 50,000 words, and with a few tables with financial data. After studying this huge data, the main issue that we realized is that there is no common structure among the filings in different companies. Even the balance sheets don't have a common format to rely upon. After a long discussion, the team came up with a tech stack to with a user-friendly interface. And to showcase the results to users easily. First of all the Edgar data will be processed, and then processed data will be uploaded to MongoDB using automated Python scripts. Only this processed data will be shown to the user interface developed on React with Node.js as the backend. Talking about the data analyzing, the data will be it will be done in three different segments. First one is the summarizer using T5 T5 base. Another one is the sentiment analysis using Finebird, and then SAS metric analysis, which is devised by the team. This was just a general overview. Now I'll be going into the details. Starting with reading the data, uh, a single call API was created to get the forms based on the company name, the time period, and the form name. The final data set is returned in the form of CSV file. Now, how are we analyzing this data? The forms have huge paragraphs which take time to read manually. So we provide users with a summary of important information from the forms. Based on this summary, we provide user with a positive sentiment score so that he or she can easily get the insight how the company is performing. For the SAS matrix, we have scrapped numerical paragraphs from the forms, and then those values are compared to SAS matrix to extract probable numbers on the company's financial performance. Going to the user interface. This is the application where the user can search for any company and get the insights to the company's performance. For example, here the Max Sound Corp is the company, and this page shows summary of 30,000 characters. Based on the summary, a positive sentiment score, like here it's 95%, uh, is seen by the user, and the user so can decide whether the company is investable or not. Then for each company, we have provided easy access to their balance sheet. And for the key SAS metrics, we have currently shown some important financial data to the user like gross profits and net income, etc. The current front end is easy to navigate and responsive and has instant toggle speed as the process data is directly uploaded on the backend. Some features that could have been added are comparison between companies and optimized SAS metrics. At last, I would like to share how our system is highly scalable. So the machine learning that is being performed on the data is abstracted out from the web app and runs on a separate high performance machine. The next thing that we did is the MongoDB database is also hosted on a different server, so that database can be scaled vertically when more data is added. The web server is hosted differently, so that the more disk space is consumed by the database does not affect the web server. An automated process of publishing summaries directly to the database. This reduces the size of the data set. Also, the initially we passed 10 GB of data and reduced it to a 90 MB file. Thank you. Any questions that you have?
Hey, this is Piyush. Thanks for the presentation. Can you talk about the model you have used for the sentiment analysis? You talk about positive and negative sentiments, right? Can you talk about what all models you have used for that?
Yes, sir. So we have used a pre-trained model, Finebird, and we trained the new data set on that.
Okay. And in the second last slide where you were showing the scalable architecture, right, for your application or for your product. So what you have done is you have put everything separately, like your DB, your web server, and your machine learning models, right? So the system becomes scalable. But did you think about the cost here about your system? Will this not be increasing? Is your system is cost effective in this case?
Hello, am I audible?
Yes, you are.
Okay, I'd like to take this up. So, to design the architecture of the system, we tried to follow the microservices approach so that, like we could abstract all the different entities out of the system so that, we followed this approach keeping in mind that when scalability is required for one service, then we do not have to spend resources and money into scaling the entire system, and that is the reason we followed this microservices approach. So that, let's say, because see, most likely it is most likely that the size of the database would increase, as more and more reports get filed. So to solve that problem, we should not have to scale the entire system of having the web app and the database and the servers that store the web app and the the models and all. So to solve that problem, scaling only one thing that grows exponentially and the other things remain constant. So in that sense, yes, it is cost effective because it requires us to invest resources in only those things which actually require scaling and not having to scale the entire monolithic architecture.
So you talk about microservices architecture here. So did you consider using containers here by any chance?
Sir, as of this, for this project specifically, we have not implemented that thing, but yes, like we have created different services for everything. Like the ML model, runs on different. So like for the as of now, we have run these manually by running. Like for example, the ML part was run on a different machine by a Python script manually. But yes, like when we scale it, when we full scale deploy it, then at that point of time will be containerizing these microservices, and then handling the networking part between them. So as of now it is not implemented, but yes, this system is designed in such a way that that can be followed.
Okay, thank you.
Thank you for presentation, everyone. This is Sumit, and I have one question. Like, can you please take me through the metrics that are being considered to declare a company is investable or not? Can you please take me to the metrics that are being considered for this?
Sorry, just a second.
So actually what we do, like we let the user decide whether the company is investable or not. We just provide the analysis of the entire form. So what we actually do is we break the form into different segments, and then for each segment, if that segment is like we summarize that segment, and based on that summary we provide a sentiment score that lies between 0 to 100%. So following the simple rule that above 60% is like the higher the score you get, the better it is. So depending on each, the entire form is divided into various segments, and those segments are summarized and given a score, and depending on that score we let the user decide whether a company is investable or not.
Okay, so if I want to dig deep into the, how the score is calculated, what are the numbers that are actually there on the report? So how can I see that, those things?
uh like as I said that we divide it into the sections. So if we can see in this example, this screenshot, that we analyze the risk factors that the company has, and depending on those factors we gave the user a summary, and then we gave a number depending on that thing. So this gives 95.67% indicates that the company is currently not facing too much risk. So that's how we let user analyze the numbers that you provide.
Okay, so this is the only metrics that you are providing to a user, right?
As of now, yes. And then we have we created a different algorithm for extracting out numbers, but as of now that is not implemented, but we do have a like concept in place to extract out the numbers from the forms.
Okay, okay. Thanks for the explanation.
This is Rajesh here. So, quick question about the format that you showed for the numbers. If you go back to where you were presenting the balance sheet metrics, how did you get these numbers that you're presenting here? Are they stored in your database and you are formatting it like this?
I think Gajraj can take this one. So we scrape these metrics out of the forms as it is, and then we pass them, and then we store them in the data. It's like this. So this is not uniform for all companies, but we store it as it is. In the exact same way it is reported in the form, and then we extract these numbers, and then we show it in the UI. Gajraj could talk more about it if he's there.
Actually, I can take ahead. So these
Okay.
balance sheet, we realized that every company didn't have a common structure of for balance sheets also. So what we were doing is directly extracting those balance sheets from the form and Depending on the time period, we can give the filters of what time do they need to see the balance sheets.
When you say form, which form are you extracting them from?
These are from 10K.
Yeah, but you are extracting this from HTML or XBRL, and how are
From
you able to? What? Yeah, go ahead.
from HTML directly.
Okay, and how do you store it? Like, are you storing the entire HTML? Because
Yes.
I see you have the formatting, everything preserved, right? So I'm just
Yes. Yes.
wondering. Okay, you're
So
storing, you're taking the entire. Yeah.
actually, React has that library where we can directly input that HTML code, and it converts to the front end. So we are storing that HTML part only.
Okay, so you're going to the SEC filings. You're identifying where the balance sheet table is, and then you are extracting the entire. You're scraping the entire HTML for that table. You're storing that in your database, and then when you're rendering it here using React, there is some utility that allows you to render that HTML.
Yes, sir.
But how will you, let's say, if you have to do analysis on these metrics, let's say you want to plot a historical revenue chart for a particular company, how would you do that if you're storing the entire HTML?
Sir, in that case, we would have to parse the HTML using regex, and then depending on that parsing, we have to extract the individual numerical key. We can store this data in key value pairs, and then depending on that, after we get the results that we get after parsing, then those results could be used for that historical revenue stuff, like
Okay,
analysis
if
part.
we go back to your architecture, so here, Edgar data pre-process that is going into ML and deep learning. What data is going into ML and deep learning here?
Okay,
Is
so
it yeah?
sorry.
Go ahead.
We scrape the entire HTML forms, and as I said, we divide these forms into different segments. So there is a specific format that is already present in the Edgar format, as that is this data is divided into different items. So like there is an item 1, and then there is a subheading to that item 1A. So we are extracting the data in the form of these paragraphs, and then individually, let me give a brief about how the database schema of our website looks like, of the data set looks like. So we extract the company data, and then we divide it into different sections on the basis of the headings that are already provided by Edgar, that is 1A, 1A, 1B, and then item 2, item 3, item 4, like this. This is the structure provided by Edgar, and then we map these item values to the actual values that are there. Like for example, let's say item 6 maps to risk factors. So that's how we map this data, and these are stored in the database according to this. And then these individual paragraphs are fed into the ML models, which run the summarizer model is run through the same paragraph, and the summary that is generated by the summarizer model is passed through the sentiment analysis, and then sentiment analysis gives us a number of that.
Okay, so I think looks like you're processing the textual sections of the filings, right? So the actual
Yeah.
financial statements, you're just taking the HTML and storing. So if you
Yeah.
have to run any sort of analysis, like that is not in what is stored in MongoDB is the the part one, part two, item one, item two, those things, and you're doing sentiment analysis and summarization. Okay, so that's fine.
And
Um,
if you
uh,
would allow me,
but
I'd like to talk a little about this that section we wrote about devised, because that is the algorithm we try to run for the numerical data.
yeah, how
Uh,
does that work? Can you show
okay,
somewhere
so
like?
like uh, So like what we do is we divide the data into three parts. So first is this textual data that we talked about. We run the sentiment and the summarizer model. Then there is the tabular data that we talked about earlier. That tabular data we display as it is by without parsing the HTML. We show the balance sheets as it is. And then about this algorithm for this creating for extracting numbers out of them. So what we do is we extract only those paragraphs which contain a proper number out in those paragraphs. So we extract sentences which have a number mentioned in that, and then we run those sentences through a different ML model, which gives us a list of most prominent or most relevant words out of those paragraphs. And then we try to match those words that we get to whether those words correspond to some SAS metric that we are trying to figure out. So this is the approach that we created to figure out the SAS metrics. Although it did not work out very well for us, but this is the approach we tried for that SAS metrics thing for extracting numbers out of the forms.
I see. Okay. But did you take, like, you could have started with, by creating a taxonomy for the SAS metrics and then going and finding like the paras that has that taxonomy or those keywords, right?
Yeah,
And,
like
and
we tried it.
what
Sorry.
part didn't work? Like, where did it fail? Like, whatever you were trying to achieve, extract the
That
numbers.
like we extracted the paragraphs which contained the numbers, then we ran those models which gave you the most prominent words present in a paragraph. But the part that failed was that these prominent tags to the paragraphs didn't really correspond much to the SAS metrics that we are trying to find, which essentially gave us the implication that the SAS metrics that we are trying to find are not directly reported in these filings, but they have to be extracted, using some other formulas, like some other formulas have to be applied to extract those numbers as it is, because we were not able to extract them as it is from the forms.
Yeah, like I think probably there you will run into, since you are storing the entire financial statements as HTML, if you have to run those formulas using metrics from financial statements, you won't be able to do that because you don't have the standard financial statements stored as metrics in your database. You have them as HTML, right?
We extracted the paragraphs which have numbers. So like we do not have those stored as those the tabular data that we don't have as numbers. But other than that, we had those paragraphs which contain numbers from within the text. So that's what we were trying to analyze.
Okay. Okay. Okay, cool. Thanks. I don't have any other question.
Yeah, thank you, team 3. You may stop presenting now. Next we have is team 18. Members from team 18. Team 18. Are there any members from team 18? Okay, so whoever is presenting from team 18 may share their screens and I'll inform when you can start presenting. presenting. Can any member respond?
Yes, ma'am.
Okay, you may start presentation at any moment.
Ma'am, one of our team members has been given attendee. He's speaking. And
Just a second. I'm back. I've invited him to stage. Kindly confirm if. Okay, okay. I think he's in. Okay, you may now begin.
This is Team 18's presentation regarding the digital alpha problem statement. Let us get started with the problem statement. SEC's Edgar database consists of a huge amount of data, including the SaaS company filings of 10K, 10Q, and 8K forms. Currently, there's no framework built to easily access certain metrics which are derived from the 10K, 10Q, 8K forms, which makes it very tedious to analyze companies' present and future health. So our main objective of this project is to build a product which acts as a middleware between common man and the company, enabling easy access to these metrics for analyzing the company's present and the future health.
so our initial line of approach. So our initial line of approach was um, to manually check for different metrics and keywords and forms. To do this, we actually collected a lot of forms from Edgar database, which included 10K and 10Q forms of SaaS companies. These SaaS companies were reputed companies like Apple, uh, Microsoft, Tesla, Netflix, Zoom, etc. We chose this company because they have abundant number of filings, which will be helpful in finding numerous different metrics. Screen sharing. Screen sharing the problem. Ma'am, there was like a slight problem in sharing of screen. Is the screen visible?
Yes, it's now visible.
Okay, sorry, ma'am, for the delay. There was slight problem in sharing screen.
You can continue your presentation.
We actually chose these companies such as Apple, Microsoft, Tesla because they have abundant number of filings. This was useful because we could find numerous distinct metrics from these files, and we also got a lot of data through which we can train our ML model. So to determine the metrics that we were using, we manually checked for each metric, but we saw that most of the companies do not disclose every metric. But some of the metrics have to be disclosed manually. So we compiled a list of metrics that were disclosed mandatorily, and we also compiled a list of metrics that were present in most of the forms. So in 10K forms, some of the metrics that we included were total current assets, liabilities, cash and cash equivalents, and even in 10K forms, some of the metrics that we chose were cash and cash equivalents, total current assets, and total current liabilities. We also had a lot of other metrics.
Coming to the project overview, we used data from two databases, namely NASDAQ and Edgar database. Our NASDAQ.py file filters out the data from NASDAQ database and gives us the close market value for a particular company. Get8k.py gives us the 8k forms in .htm format. Both these data are then given to the model for training and future prediction. Our webpage consists of features wherein, given a company name and date range, one can easily view plots of various different metrics for different companies to analyze the company's future and present standing in the market. This is done using the FinHub API, which is a powerful API gathering financial information of companies from 10K 10Q forms. Another feature included in our webpage is that the user can search a company's name using keywords, which outputs the prediction of company's future health based on previously filed forms.
Coming to the structure of our web page, on opening our web page contains a predictive search bar that takes the name of a company as input and the date range, start date and end range. On clicking search, the data will be displayed in 3 tabs. The first tab being 10K analysis tab. This tab contains plots for metrics that are present in 10K forms. Next tab contains 10Q analysis. 10Q analysis. This tab contains plots for metrics that are present in 10Q forms. For example, here we can see revenue. This revenue is obtained through a JSON file, and this JSON file is then plotted using graph in our web page. Next is the market predictor tab. This tab shows the stock values of the given company for the given date range and predicts the company growth in the future using MLP classifier model. So as you can see, there is a stock value plot, and below that we can see whether the market will fall, will rise, or remain neutral using an MLP classifier. Nirmit is going to explain it in more detail.
The model that we've used predicts the company's future performance based on the past data, which we've taken from the 8K forms derived from the Edgar database. 8K forms hold valuable information, which we've used for predicting the company's future performance. Also, the data retrieved from the Edgar database is an HTML form, which needs to be read in a very specific format in order to give it to the model, feed it to the model, and train the model, and also use it for future predictions. Moving on, here are some obstacles encountered through the way. First and foremost, we've had to choose between a supervised and an unsupervised learning model. We chose the supervised model, where the target columns were 3 classes, namely positive, negative, and neutral, which correspond to the growth, loss, and neutral performance of the company. The second obstacle we encountered was the input received that was in the HTML format, and it was difficult to pass through and feed it into the data. In order to tackle that, we've used Beautiful Soup and also other standard NLP procedures to convert the data by means of vectorization, removal of stopwords, etc., which takes out the important keywords from the text file, which are responsible for the prediction. The third obstacle which we encountered was figuring out the stock price from the 8K files itself, which is not at all possible because 8K files mostly don't have the stock values. Also, it was important because in order to classify each 8K file into 3 classes, we need this stock price of that company in the same date range when the file was formed in order to classify that 8K file. So in order to do that, we use the APIs which lend us the data directly from the stock exchanges for the closed stock market values of the company on a given date range. Moving on, our model takes the input as basically an 8K file, which is then pre-processed and passed by many procedures. Mainly it is in HTML form, so we need to convert it into human readable form, out of which we then take out the keywords which are responsible for the company's growth and future prospects. Uh, all that is done using in standard NLP procedures like vectorization, tokenization, removal of stop words, etc. And the model gives output as one of the three classes, namely positive, negative, and neutral, which I've talked about. Positive corresponds to the growth of the company in future, which in the training data has been accounted for as the positive relative growth that must be more than 2% according to the change in stock prices. And likewise, a negative class has been allocated to an 8K file when the relative change of the stock values of the company is less than 2% in that date range, and otherwise we have allocated neutral class to the 8K file. So this was the output of the model. Also, here we have mentioned some libraries that we've used, which are standard libraries in Python. Moving on, here are the accuracies and predictions. So basically, our model is a multi-layer perceptron classifier with cross-entropy loss function. These are some technical details, and based upon this, we've built the model. Here are some accuracy or the performance of our model, which is 80%, recall is 0.9, etc. So, basically, our AI model has three hidden layers, each of which has three neurons, and the output layers is only three neurons, each corresponding to one of the output classes. From here on, Samrita will take over.
Hey, hope I'm audible. Can someone please confirm?
Yes, you're audible.
Sure. And I hope my screen is visible as well. So we have covered all these things. Let's see what are the features of our product right now. So the features include these exact things. So I'll go over each and every point in detail. Firstly, our product gives you like some tools and metrics that you can use to analyze the data from the Edgar database and the national database. So firstly, what we have here is, so here we have some liabilities, assets, and market values. So basically, when you go to some when you take this data, so and someone wants to analyze the data, so they have to know the exact metrics using which they have to analyze. So all of those things we have bundled up in one web app, and we have presented to you this product. So what this product will do is, it will take all the data and company with respect to the company name and dates and whatever data we will be giving to the front end, and it will analyze data from that date range for that company, and it will return us the data, so that whenever we are getting the data, it is totally well polished and uh, well made, so that anyone can see to it and understand what it is doing. So that is a basic idea of what we're doing, right? So next is this abstraction of data. So what we are doing is, here we're taking all the filings submitted by the companies, right? And but these filings can be very lengthy. So within this HTML pages, what we are doing is, we are taking the data from the okay, so we're taking the data from these pages, and we are plotting these data and showing them visually. Also, we are giving some predictions so as to let the users know about the market of the current company. Next, we have how we also have this investing options. So let's say you don't know. So let's say you don't know how to invest in a company. So what our product will do is, our product will give you some a front end UI where you can see the company's previous metrics and also the how it will progress in the future. According to that, you can choose whether to invest in a company. Also, let's see what you cannot decide if you want, if you should invest in company one, company two. So what you can do is we also have a place where you can directly compare these two companies, and you can see what like how each one company is faring with respect to the other. That way, you can have a more clear idea about which company you should invest in. Also, our product is made so that it's totally scalable. As of now, we have not got time to implement like the things like, for example, consumer base and stuff like that. But we have home for making those things, and also the cost, like it is also cost productive because at the end of the day, we have made everything as a microservice and as independent as it can be. So that was for the presentation. Thank you and have a nice day.
Judges, if you have any questions, we
Yes,
can start with the Q&A session.
thanks for the presentation, guys. So if you go back to the model that you were using, if you share the presentation and go back to the model.
Sure, I'll do it in a minute.
So, like looks like the model is right now applied only on the 8K data. Is that right?
Yes, sir, the model is only applied on the 8K data.
Okay. And what are we getting out of this? Like the signals that we're getting out of this. What signals are we getting by reading through the 8K?
So, like reading through the 8K file, the model will classify each 8K file into one of the three classes, which is positive, negative, and neutral. Positive implies that we expect the company to grow in the future, and respectively.
Okay, so basically, apart from sentiment analysis, are we doing anything else like on the data? Like, is there any extraction of data that is involved? Like, I know you mentioned customer metrics you were not able to find, but did you apply any models that are used to extract the data from textual portion of the filings?
So we used Python libraries like Beautiful Soup in order to extract the textual data from .htm format to convert them into the tokenized words.
Yeah, but that's like textual data. But how about extracting numbers from the textual data? Let's say if you're interested, if the filing is talking about ARR, and if you want to extract that ARR number from the text portion of the filing, did you solve that problem?
Sir, actually, uh, we tried manually trying to find the customer statistics of companies in 10K and 10K forms, but the distribution was not enough. Like, we didn't get enough data to do the analysis for customer statistics. So we used the 10K and 10K forms to get quantitative metrics, and we use the 8K forms for qualitative analysis of text uh, to predict. And we also used the stock market values of the company, and we use this to create a model that outputs whether uh, the market will rise or fall in the future.
Okay. And the role of FinHub API, Like, in order to get any financial data, were you purely dependent on that API, or you also have some code that extracts the metrics independently without depending on this API?
Uh, Sir, actually, for now we have implemented extraction of the metrics using the API, FinHub
Okay.
API.
And what are the
Because
limitations? Like, is it like 100% open source?
no, sir, it is open source. FinHub is open source, uh, but like some of the most of the time they use 10K and 10Q forms for analysis, and most of the time uh, the keywords that they use may not be the different companies may use different keywords for the same metric. So sometimes we had to use like substring analysis to check for the same metric. So using this, we took those metrics which are present in most of the files, and we used that to plot the graphs in our page.
But what are the limitations? Like, are there number of API calls that you can make per day to
Plus,
FinHub? Or
there's around 100 to 300 per 10 per second, 10 per second, around 10 per second. So around maybe 80 to 100 per minute, something.
but is there I think is there a limit? I think
Yes, sir. Per second, you can go around 80 to 100 API calls. There's a
okay. But is there an overall limit? Like you can only make these many calls per month?
there is no overall limit as such. The limit is just for a period of time, like 1 second. You can only do 10. That's
Yeah.
it's
Okay.
an open source
Okay. But I
financial.
think the documentation says if your limit is exceeded, you will receive a response with status code 429. And it's a commercial product, right? Looks like they have multiple plans. Like again, I'm trying to see what kind of ceilings you will hit by using this data, like using this API.
I think I will take this up. Firstly, like for the FinHub part, we don't have like much restrictions with respect to the upper limit. However, for the hello, yeah. So, however, for the Edgar APIs like the SEC API, we have a limit of 100 API calls per month. I think that was the limit or something. Like for or per, I don't think it was per month, but it was. I remember it was 100 API calls. So, if we want to like make infinite call, unlimited calls, then we have to upgrade it to some like premium account or something.
Yeah. Okay. Okay. Cool. Sounds good. I don't have any other questions.
Hey, thanks for the presentation, team. Can you talk about the hosting solution for your product?
Okay. So as of the hosting solution, we have hosted the backend in Heroku, both the Django and Node.js backends in Heroku. And however, the front end we were supposed to host on Netlify, but there was some issue with the hosting, so we could not actually uh, make the website live on the hosting platform. But yeah, the backend has been hosted on Heroku. That it was hosted correctly. The front end hosting we tried to do on Netlify, but there was some issue with the this directories. Like there was this build directory which we missed, so we could not really host it correctly.
Okay, is there any slide here in your deck on the hosting solution?
As we could not host it properly, so we did not prepare a slide for it as of now.
Okay, thanks.
Team 18, you may stop presenting now. Next, we have Team 4.
Sure. Thanks a lot.
So I request Team 4 members to kindly raise their hands. I think there are only 3 presenters from Team 4. So, Team 4, any member can start sharing their screen. Okay, you may start presentation.
Good evening, everyone. We are Team 4, and today we are going to present our solution for the SSE Feeling Analyzer. So, basically, the problem statement we had to extract the various matrices that are useful to analyze any SaaS organization, and we have worked upon that. And let's start.
Hello everyone, hope I am audible. So the first thing we are going to discuss is the architecture of our application. And so every web application has a front end and the back end, that and the front end directly interacts with the user through data request and displays the result. So in the web application there are mainly four layers: the presentation layer, business layer, data access layer, and the database layer. And in the large scale complicated web app, there may be more layers or there may be less. And so the present so the we'll discuss each and every layer in details. So the presentation layer contains the UI components, and it contains the entire front end of the website. In our case, we use the React.js library to develop the front end and the user interactable components in the website. We have also used charts to display the important SaaS matrices of organizations using the chart.js library available within React. So in that way, dis- we have displayed four charts that describe the SaaS matrices of every company. And so I would like to show one of our one of the apps of one of the sample matrices. So here we can see that there is we can select a company from here, and so the charts will render for that company. So we have four charts here: the future growth potential, the assets chart, the debt chart, and the cash flow chart. And we have displayed the charts for uh, last 3 to 4 years for each of these parameters. So going back to the slide, so and after the presentation layer comes the business layer and persistence layer. So for our app, for our website, the business layer and persistent layer are more or less similar, because they perform the similar operation. The business layer actually defines the how we analyze, how we manipulate and calculate the data and send it to the front end for displaying the data in the chart format. And the persistence layer actually collects the data from the backend database, which is actually the SEC fillings. And so we have used SEC APIs that are available in the SEC website for different organizations, and we have extracted the data from there. So these are the APIs that we have used. XBRL. So this is the API that we have used for the purpose, and the APIs are the data is actually received in the front end, and then manipulated and displayed in the database in the charts. I'm sorry. So this is the structure of our web application, and now we'll be moving on to the ML part.
Hello, Yash. Are you there?
Yeah, we can hear you. Please go ahead.
Okay, I think so. Yash was presenting this, but he has some technical issues. So let's go ahead. So we have found some factors going through the various 10K, 10Q, and forms, and then we find out that inventory values, assets, and long-term debts, and the cash that organization has shows what are the future potentials. And on the basis of this, we have extracted the various matrices that we have showed in a solution. So next slide. Yeah, so this is what we have extracted, and then we have various other things. Then we finalized on this four matrices, and for the various organizations, we have displayed them. So finally, if I would like to conclude that on what basis the SaaS organizations are. So basically, the SaaS organizations are customer centric. So more the customers they are gaining per year, shows a positive side for the SaaS companies. But as we were not able to extract the exact data for the different years. So yes, can you continue?
Am I audible now?
Yeah, yeah.
Okay, cool. So we found that we made a metric, that a novel metric that we called as the future potential. The future potential was composed of three main factors: the assets, the long-term debt, and cash flow. We found that none of these factors in isolation could accurately predict the company's future growth, and the four very important SaaS metrics, which are profitability, cash, growth, and market share. So based on these, we took a combined aggregate of all these values, and we found that it accurately represented the growth of the company. So each of these, if taken in isolation, would not have such a accurate prediction, but together we found that these were very reliable indicators. Now we'll move on to the conclusion. So we saw that they were for the machine learning part, as we saw before, there were over 16 factors, and we took out of those we manually selected four to be the representative values. Here we'll see that the four metrics that SaaS companies are very like dependent on. So they're very customer centric. The customer growth is a very important factor for them, and how much is the CAC is another major thing to note. The yearly and quarterly revenues that we found from the 8K and the 10K forms were again a very important part for us. So next slide, please. So this is the drill down overlay of what we found were the factors that we should optimize for. Any SaaS company would definitely want to take a look at this to find where they lack and where they could optimize for them. So for example, if you take profitability, then the CAC, the net RRR, and the profitability per employee are very relevant to those companies. Now we'll move on to the more ideas and improvements that we think that we could perform in the future.
So the further improvements that we thought upon that could improve our overall analysis, like we could incorporate various NLP approaches. So recently we have seen that in the financial world there are various sentiment analysis models. So there are various BART-based sentiment analysis models. So we can incorporate them to have a more clear picture about the various matrices, and it would give the further much detail. So like we tried to build upon all this NLP models, but we couldn't finally incorporate that in our solution, but we further plan to have them in a final solution. So that was all. Thank you. So any questions from the panelists?
Yes, thank you for the presentation, everyone. Can you please take me through the technology stack that you guys been using? I see you explained the technology stack that is being used in the hosting solution, but I don't see the technology stack that is being used. Where you are doing the scraping part, you're using the machine learning part. So can you take me through the technology stack that are being used on those components?
Yeah, so basically, the API that we have shown, that is the SEC API. So to get our data, we have used that API. So basically, that gives us data in the XBRL formats. So on various taxonomies, we can filter out our data. So the assets values and cash flow values and other values, we were easily able to extract through that. And on the basis of that, we have created our final approach.
Okay, okay. And
Like,
I have one more
can you
question.
also
Yeah.
show that website of that API? Yeah.
Yes, yes, this is
Yeah.
the.
So there were various parameters, and on the basis of that, we have extracted our data.
Okay.
So the majority of the data is extracted from the Edgar database, and we found that it was a good representation and had a vast majority of the data available for most companies.
Okay. Can you move to the slides where you are classifying the data and you're using the different dimensions to classify the data into different classes?
So you mean the machine learning part
Yeah.
that
Yes.
we are
Yes.
okay, right? So can you go to slide 7 actually? Yeah. So basically, right, your question is,
Yes.
can you say?
So basically, yes. So there are the previous slide there where you have mentioned the dimensions that you have been considering to predict the class, right? You've been. Uh,
Yeah, so
Right.
on the
So
basis of NLP approaches, we were trying to predict all these things, but as I told that we were not successful in that, so that we are proposed that in the future. So on the basis of the BERT models, we were trying to extract this on the basis of various XBRL taxonomies. We all then we move forward and extracted a few things from the SEC APIs, like revenues and then cash flows and all. So on the basis of them, we have created a final.
okay. So how much
since we were
variation
not
in the data?
uh,
Yeah. Go ahead.
just a point. Since we were not successful in utilizing NLP, we actually used a support vector machine classifier to choose the factors that we found were most relevant. We considered over 16 taxonomies and part of the US GAAP terms, and out of those, we selected 4 of them which were found to be most relevant for companies. Those 4 were manually selected because they were found that they had a major effect on the future growth of the company.
Alrighty. Thanks. I'll open the stage to my colleagues for if they have any questions.
So one quick question, like in this slide, you've identified cash and cash equivalents, inventory, asset, assets, and long-term debt, right? So for
Yes,
SaaS companies, since our universe of companies that we are researching on are SaaS companies, why are these things relevant to SaaS companies? Why is, let's say, for example, inventory? Why did like how did you what kind of analysis did you do to come up to identify these factors as future potential?
the basic thing was that it wasn't selected at by ourselves. These factors were found to be most relevant by the machine learning model, by the SVM classifier, and based on this, we selected those. We found that these 4 in aggregate were a good representation of the future growth potential metric that we have shown in the charts, which is the first
Okay,
chart for
so
every company.
so in order to say that, we should have done some sort of back testing, right? So you did some back testing. Let's say, for example, if we go back last 20 years, assuming that we have SaaS companies, and we looked at these four factors and we looked at the future growth for those companies in the last 20 years. By doing that back testing, I'm just asking, I don't know what is behind the what is done as part of the SVM. By doing that, we know that, okay, so if these four factors are at a certain level for a company, it tend to grow at a certain rate in the future. Like, did that go into the SVM modeling that you do? How exactly did SVM come up with these four? Based on
Okay,
what?
so it was somewhat similar to what you were saying, but there are a few key differences. We selected a few objective functions, which are the goals that we want to maximize for our company. We can say that when these objectives are fulfilled, we the company is being successful, and we can call it a net positive for the company. So for that, we saw the stock price from the Nasdaq, we saw the market share growth, and we saw the profitability. Over these three objective functions, we analyzed over these, and then these four factors were chosen, because these four factors by themselves could predict the stock price, the market share, and the profitability very well.
And this is applied on SaaS companies, the universe, like the 130 companies that you are
Yeah,
working
the
with.
SaaS companies on the SEC Edgar database, not specifically all the SaaS companies, but the ones that were provided in the list, the
And
292 companies.
okay, and this is available in your GitHub repository, which basically shows that inventory and long-term debt are tied to how you can predict the stock price and the market share of the company. Because the
So
reason
the
why I ask is, for the SaaS companies, inventory is not that relevant, right? So they're not like a
Right. So,
manufacturing.
so actually, we eliminated it for SaaS companies. You can see from the next slide that inventory value was found to be not relevant for SaaS companies. This was a general term that inventory value and all these were relevant for all the companies found in the SEC Edgar database, but specifically for SaaS companies, cash and cash equivalent flow, asset value, and long-term debt were found to be most relevant.
Okay, I would
So
suspect
there's a mismatch between any general company and a SaaS company, in which we selected only these three: cash and cash equivalent flow, assets, and long-term debt.
Okay, I would suspect even long-term debt. It would be interesting to look at what that backtesting data looks like, because most of these companies are, venture funded and then came into IPO, right? They don't carry, and they're not capital intensive businesses. They're very they don't take on a lot of debt. Like,
So another specialty of our SVM classifier is that we have factors that, for example, if a factor is not that important, we found it to be somewhat important, but if a factor is not that important, then it has a coefficient, and every coefficient varies from 0 to 1, or maybe even negative, right? So if something is not very important, it will have a coefficient closer to 0, but if something has is
so
very
do
relevant, then it
so do
will have
we
a
have
coefficient.
a do we have a weighting on these three things? Like, in, let's say, for example, if we are saying these three kind of drive the market share and the stock price of a company, do we know what kind of influence each of these factors um, have?
So we were unable to analyze it on the tens of GBs of data that were found in the SEC database. So we do not have hard values as of now.
Okay, for the SVM, how many years of uh, mm, data is provided? Like, in order to come up with this
So to
analysis.
select the feature matrix over, I think around 10 years of data was there. That is why it ran into the GBs for the companies that were present in the database.
Okay. Okay, cool. Thank you.
I think team 4, if you have completed your presentations, you may stop sharing your screen. Next we have is Team 14. So I request members from Team 14 to kindly raise their hands. Okay, you may start presenting your screens and I'll inform when you can start.
Just confirming, am I audible and visible?
Yeah. Your sound is a little less, so if you can hold your mic closer.
Is it any better?
Yeah. Rajesh sir, can you please confirm?
I can't hear that well, but if that's the best, maybe we should just move on.
How about now, sir?
Yeah, better, little better.
Yeah, it's better.
Okay. Like if you guys give me enough time, I'll maybe make some settings on my laptop which will make enhance my mic sound. So, or is this okay?
No, no, this is much better now.
All right. um, will I be told when to start, or should I?
You can start.
All right. Good evening, everyone. We are Team 14 here to solve a problem that could potentially change the way people operate in the world of investing and finance. In the current scenario, investing is a risky business. The end users are more aware than ever. They want to research more and take data backed decisions. The current systems like money control that get their data from NSE BSE show recent gross numbers but do nothing to tell you about the inner health of the company. Through this PS, we recognize the need for a single stop solution that would ensure an intelligent investment on the part of novice and expert investors alike through an elaborated dashboard with easy to understand graphs that clearly show the history and the present of a company. Another problem we recognized was that several metrics are required to find the health of the company, but the data points are not easily accessible through all of these metrics, which leads to an opportunity for immoral companies to inflate data and play with it. Through this solution, we can create easy access to data points that are generally not accessible. So now let's dive deeper into the dashboard that we have developed through which anyone would be able to pull up information and related statistics about any SaaS company they are interested in and extract useful information with ease rather than reading voluminous filings that are often 50 to 100,000 words in length. Okay. So now beginning on talking about the data extraction engine, which is the core of the solution. The identification of actual data of interest and the construction of a pipeline to capture most of the useful bits was a challenging task. The organized data from filings, especially 10K and 10Q, was must be pre pre-processed in a way to address maximum abnormalities that can be fetched. We figured out that each filing comes up with an interactive user interface similar to looking up Excel files divided in sections. Now, understanding the importance of these Excel sheets, we urgently needed some API or an open source software to download this useful piece of information. We did not end up finding anything like that. So failing to find an API was a bottleneck. So we decided to build a bot ourselves does not only retrieve data according to a fixed set of rules, but is customizable. So if we want to change any specifications we are chasing for, we can do that. For example, change the form type or the data range. Coming to the specifications, first of all, any data that has to be retrieved needs to be needs to have its company CIK number and the accession number associated with it. We first downloaded from a reliable source, that was a text file containing the company names and the CIK numbers, to give us most of the CIK numbers, and 20% of the remaining companies we did manually. Having done that, the next task was to get the Excel sheets for which we iterated all on the company CIKs and send that as a key along with the data range and the form type that we wish to extract the filings for. However, the sheets of some companies were not following that pattern, so we set up a whole different setup for that. Um, Once the retrieval is done, we get to obtain the net revenue and EBITDA change for the specified company. The EBITDA change was present in the 10K filings for most of the companies for which we fetched the data. The EBITDA change had a varying name schema, which made it difficult to extract it from the forms. We tackled this by making various test cases and like doing them individually then. A similar approach was applied to get the net revenue. We made a robust function to handle variant data formats, different sheet names, different synonyms for revenue terms. Stock performance graph is another very important visualization and is present in the raw filings of 10K in most of these companies, which made the for which we made the bot to really retrieve the URLs of these images. Okay, uh, is the screen stuck for me? Okay. So the metrics need to be chosen very carefully for the system to have value. SaaS companies are customer driven and are heavily dependent on their customer base. There are a set of metrics that can showcase the health of the SaaS company and their aspects. These metrics and numbers are not readily available on publicly reported SEC filings and need to be chalked out from the available forms. Accessing these metrics can be of tremendous value to the right users. Various companies have had different patterns of filings or reports, and the reports consist of multiple sections containing relevant information. As the reports didn't follow a particular order, finding a specific metric in most of these filings wasn't easy. Our approach for was that we took for most of the companies we were able to grab almost all the metrics. Various metrics that we found relevant in the context of SaaS companies are profit revenue, that is the percentage in profit and revenue over the past years that can tell us the rate at which the company is expanding its business. Customer growth rate. Customers are everything in the SaaS business, and the growth rate speaks about the future prospects of the company. The CAC, the customer acquisition cost, is important because it signifies probability and customer revenue. EBITDA is one of the most important metrics that can be used and is a snapshot of the net income before accounting or for other factors such as interest, before accounting other factors like interest, taxes, or depreciation of assets. Then there's the free cash flow. It's a helpful indicator for liquidity that provides information to management and investors about the amount of cash generated from the company's operations. Then there is ARR. It is one of the metrics by which SaaS companies swear by. It is so because a company expects to receive revenue year by year, and any growth creates exponential growth in value. Lastly, we have the stock performance graph. It tells how the company performs relative to other companies or the same or different type. Okay. Since we have used a rule-based approach, which is far more computationally cheaper and faster, we have discarded the data which is unnecessary to store, that being some text data. The Excel sheets for which we wish to extract metrics had anomalies in the form of variable sheet names and different terminologies for revenue and profit, etc. So we identified those names and made a hierarchy according to capture the maximum data. In order to capture if you're so we had this whole we talked to the users to get an insight into this problem. So in order to shape our users, we decided to run this short research which included user calls. We have asked the following questions to the users. Like, these were one of few of the questions we asked: that how much time do they on an average spend per week looking into the markets or the company reports? What are few things that you feel are missing from the platforms? So on the basis of these questions, we got insights into whether these users were beginners or seasoned investors. Some spent very little time because they were not sure what data points to look into. Most users were like long time users of Money Control and Bloomberg. They had lack of the guidance, clarity on what important data is. What they like this sometimes felt too much data and less interaction with the experts. So that is how we shaped a dashboard. We'll be just coming to that. Our primary goal was to make the application scalable and easily integratable with the Python scraping operations for this problem. Keeping that in mind, we went with Django for our backend server and went with MySQL for the database as it is scalable and it was easier for us to integrate it with the backend web scrape data. Our approach was to fetch and analyze SEC filings for key metrics, and as we know, SEC filings get updated quarterly or half yearly, so we went with a pre-fetch strategy. In this process, we scrape the data and do the computations beforehand and store it in a database. Then we make API endpoints in the backend, which supplies the stored data from the database to the front end. This decreases the overall computation per API call drastically. This optimizes the content loading in a web page to a great extent. As a rough estimate, the real-time fetch data will take at least 10 seconds to load, while our method will take a maximum of 1 second, which is more than 10 times faster. So we are using 4 API endpoints which are made by us, like the company list API. The primary utility of this API is to provide a list of companies to the users to help the user search through a database. The company slug API, which when we manage a massive database with lots of entries, we need to take care of the uniqueness of each entry. So that's where the API is used for. The EBITDA API, this API queries the SQL and returns the EBITDA metrics data as a response to the front end. The revenue API, this API queries the SQL and returns the revenue metrics data as a response to the front end. So now let's quickly go over the workflow of the dashboard. When a front end loads, it takes a single search API call to the backend, which loads all the company names in the front end. The reason to do so is to minimize loading speed of the front end, improving the user experience. Then the user clicks on the search bar and it shows a list of companies available. Moreover, the user will get suggestions as soon as the user types something and the computation happens locally, decreasing the server load. Now, when the user clicks on the list of available companies, the company page loads, which makes it a total of 3 API calls. We have divided them in multiple APIs following microservice architecture, which reduces the load on server and makes the server more scalable and load tolerant. Now, coming to the front end, our main aim was to choose a tech stack to have the fastest loading times and have a good SEO optimizations. Thinking all these in mind, we chose Next.js to make a front end. Next.js is a React.js framework but have some key advantages over React.js. Next.js, being a SSR framework, has built-in SEO optimizations, which is important to us to rank our web page better in Google search results. Moreover, as Next.js is SSR, all the computations happen in the server before the page gets loaded, unlike React.js, which is much faster compared to the client-side computations. Moreover, as Next.js is a framework over React.js, we can use the vast range of React libraries to improve our development process. Now, when we thought about deployment, our first aim was a web app that becomes scalable as possible. For this reason, we chose AWS Elastic Beanstalk, which scales by itself as per the load of the server. Our front end is deployed at Varsal, which is an optimized place to deploy Next.js applications. Now, talking about the UI of the site, we have expressly designed for the usability and scaling. We have studied user behavior as I told about before, about searching information and mapping them to proper mental models. In this case, you may look at the homepage. It follows a very minimalistic search bar, similar to how Google does it. This decreases the cognitive load and helps to make a decision faster. The basic flow of the screens goes like the user searches the company's name through the search bar, and then we click on enter. Then they are taken to a detailed analysis of the company's reports. Here they can see various graphs and stuff. So like we have provided a watch list feature. The idea is that we need to make a foundation for a product where the user searches for specific companies' reports and creates a watch list for upcoming investments. Talking about the dashboard features, we have implemented some very essential features in our dashboard. Some of them are the search functionality, where the user can search for various SaaS companies of their choice, the data visualization feature, one of the most important features, where all the metrics are shown in the form of a graph, which is more appealing to a user than raw data, especially for the novice users. User authentication is implemented through native auth and JWT, and all the sensitive data is encrypted to ensure utmost user privacy. The full web page was made keeping in mind all the screen size, which ensures consistent user experience for all users. We've also made a web app a progressive web app, which helps the user to access a web app service with great ease. While deploying this project, in every step of the way, we thought of how we can innovate new features in the existing proposed solution. These are some of the innovations over our current solution. Creation of a tabular comparison feature, which can allow the user to compare two or more companies at the same time, side by side, to have a comparative perspective of how the company is performing as per the competition. The automated sync up, which we use a pre-computed database in the architecture as I showed above. That was very efficient because it saved the time in which it is loading, and also that we know that the SEC filings are quarterly and half yearly. But uh, although that was a very efficient approach, it's not real time. So we can also have a database updated at the same time using Kubernetes cron job. We will deploy a cron job that will get triggered every 4 months, and edit the database after running the computations on newly fetched data. This will solve the problem of a backdated database. Our UX will also not be compromised, giving the same responsiveness as before. Lastly, we can also add a wishlist feature to the authenticated users. I'm just done. Keeping the performance of their favorite companies at a greater ease without even going through the searching hassle. That is it. We are done. That is a solution. We are open for questions and feedback.
Thank you. Thanks for the presentation. If you go back to your workflow, end-to-end workflow, and like looking at your GitHub and what you just talked about, how much of this is actually in GitHub and functional on the website that link of which you shared in the report?
I would like to answer this question. In the GitHub which we shared, all the Python scraping codes are there, and the front end and the back end codes, the API endpoints, the server which we deployed, all the codes are mentioned in the GitHub repo which we shared. In the front end also, the Next.js repo is shared with you, and all the things which are mentioned here, they are all implemented. Maybe, yeah.
I was
Follow
looking for there was a slide which showed a bunch of charts.
Yeah, the metrics, all the metrics which are there on the slide. That can you please move on to that slide once, Shivam? Yeah, go for. Yeah,
Yeah.
yeah. This
Looking
was a
one.
UI wireframe which was made for the overall implementation of the site. From here, all the things are not implemented, but this was the overall layer which is started to follow. The search bar is implemented and the company metrics are implemented. Till now, the overview and the recent news sections is still not implemented.
Okay. If we go to your site now, the UI that you have.
Just to add on what Shubhrajyoti said, we have implemented a bunch of metrics, but because of the time constraints, we could not
Yeah, that's
implement
fine.
all of them. Right.
Yeah, that's fine. I think I wasn't sure if I was looking at the right. If I was looking at the right stuff on the website, maybe you can quickly show whatever that is there. Sometimes these clicks are kind of hidden somewhere. Do you think you will be able to open the website?
I'm sorry, could you please repeat?
Can you open your application, your
Of
front-end
course.
application?
Subrajyoti, could you please open the application?
Yeah, wait a second.
Sorry, while maybe other panelists can go with other questions while you are bringing up the application.
Yes.
So what are the pointers which makes you to choose a relational database for this product over the non NoSQL database, because most of the data is unstructured and can be more easily handled by the NoSQL database here.
Sir, I get your point that a NoSQL database is also possible, but we looked at the future of this project. Like till now, all the metrics which are shown here are maybe not so related, but in the future, we thought about that maybe we can find some metrics which are related to each other. So the storing of the data is is an important part where we try to find that if a matrix is related to other metrics. So to keep that scope opportunity on for our future, we stuck with the relational database so that we can link one matrix with another matrix. Because all the metrics data are stored in the database, it will be easier for us to link them in the future.
Okay.
Are the questions Q&A session over, judges?
Madhav, can you please
Yeah.
present the site? I'm giving you the link of the site. I'm
All
actually
right.
having some problems in sharing the
Yeah, yeah.
site. Wait a second. I'm sorry for the delay. Madhav, can you share the site?
Yeah, Shivam is just gonna present it. Any other questions in the meantime, sir? What? क्या हुआ भाई ये? Yeah, is it audible? Is it visible on the screen?
Yeah, we can see it. Like if you, let's say if you pick a company, pick any company. Yeah. Pick something else, maybe a different company.
Shivam, can you just click on the first company itself, which is popping up? Yeah.
Yeah. So what I saw these two tabs. Like other than these, what is there? Like is that arrow like the one that is next to the EBITDA? Is that going to take somewhere?
I would like to address this question. So currently we have calculated this EBITDA and net revenue and stored in our database, but we have also extracted stock performance graph and the JSON files we have extracted that, but we have still not deployed it, but we have stored it in a way that can be easily accessed according to the date range that the user wishes to.
So that is completely customizable. And if let's say I want to see stock performance graph from 19 to year 2019 to 20, I can see that. We just need to deploy it, and we have already the data.
Okay, so other than that, what do we have? We have EBITDA, we have revenue, we have stock performance. Other than that, what functionality is available in the code that is checked in, and which like let's say if you have 1 or 2 days, what are the things that you can actually bring in here to the UI?
Yes. So Shivam, would you like to answer that question?
So, so we had customer acquisition costs almost completed, but due to time constraints, we could not deploy it. So, um,
How did you
ARR.
extract the customer acquisition cost? Like maybe you can flip back to your presentation now. If you can take us through the process that you use to extract the customer acquisition cost.
Sure, just a second. Um, so essentially, in item 2, there was a paragraph which said, just a second, I'll just share. Uh, Yes, so there were the number of customers in item 2 of the form 10K. Please correct me, Arnab, if I'm wrong. So, and we're going to use that and across different years to find out the customer growth rate and the number of customer changed, which would also be found, which would also give us the churn rate. And the customer acquisition cost would be found out using the expenses divided by the number of customers acquired in that particular year.
Was it consistently available for the how many what's the total number of companies that you were working with?
So can I answer that question about the specifications of how will we do that customers?
Sure.
Cool. So first of all, if we see that under item 2, there is a paragraph under which first of all our approach is to get that particular paragraph and then tokenize it into sentences, and we will use various and a single NLP model to create synonyms of particular words that we are chasing for. Let's say we are chasing for end customers, this particular term, but in some other sheets this may not be the case. Other terminologies like instead of end customers, you can get registered users and sort of that. So we will use back translation to in which we will convert this English language to some other language and then back to English language. So we will get this semantics of this particular words, and after that we will only consider those sentences in which these particular things are present, like let's say end customer. So after that we will create a relational model which will map these particular numbers to the words that we have feed into our model, which eventually will give us a number that will help us to decide whether this particular number is relevant for us. Let's say in a particular sentence the number is not present, so we will set a threshold to to negate all that false information that might come in, and with this we will get the number of customers for a particular time period. Now coming to that expenses, the expenses is available in the Excel files which we have extracted for the companies, and with this particular things we can create this customer acquisition cost and put it in our website.
Okay, so you've extracted all the metrics from the Excel files of the full universe, like the 130 companies?
All the listed companies, we found out that due to some anomalies some data was not available. Let's say let's just take the example of revenue here. So out of 290 all the listed companies, we were able to fetch data for let's say around 200 companies, and out of that in some of the companies the data was just not present. We have tried multiple cases, and in our code it is also visible that we have dry run on various cases, and we found that out of that only 6 companies that were listed were not having that particular metrics, and out of and all the data we have currently, we were able to extract this particular metrics. So have keep in mind the the variability that may occur. So yes.
Okay, thank you.
Team members, you can now stop your presentation.
We'd really appreciate any feedbacks from the judges, if we can.
Rajesh sir, would you like to take up
Yeah,
that?
feedback will be through the scoring, right? So you will get the feedback.
Yeah.
All right, sir. Thank you very much. Thank you very much.
Okay, next we have is Team 17. Team 17 members, could you please raise your hands?
Are we audible?
Yeah.
Just a quick audio check.
Thank you.
Am I audible? Niyati?
Yeah, you're audible, Akash.
Yeah, you can share your screens and I'll inform you when to start.
Just a second. I hope my screen is visible.
Yes, Niyati.
Please give us the time to start with the countdown, preferably.
You can start presenting now.
All right. Namaste, everyone. We are Team 17, and let us start here with a quick teaser trailer of the project that we've built. So let me walk you through the process that we're going to follow today for our presentation. We're going to talk about the current scenario and need, and then our interpretation of the problem statement. We're going to tell you about a solution architecture, which includes web scraping, the key SAS matrix, and the role of machine learning. We will talk about scalability and sustainability, and lastly, discuss further scope for improvement, after which will be followed a quick live demo. So we have seen that investment was something that was niche before, but has become mainstream now all over the world. Even in India, the knowledge and exposure has grown exponentially in the pandemic. The general public is now asking questions like where to invest, how does one decide, what to look for? And the answer to all of these questions comes from numbers. As Warren Buffett famously said, never invest in a business you cannot understand. And this is where our problem statement comes in. The primary, free, and official place to get all of these numbers, all of these statistics, to understand the financial health of a company are SEC filings. But SEC filings are notoriously long, difficult to navigate and understand, and going through them manually for any user is highly ineffective. We aim to provide a simplified dashboard that covers all of this, the display of documents, the raw data, the relevant analysis, all on a single click to the user. The SEC filings are mandatory to be filed by all companies, and they provide an in-depth detail about the various financial factors to the public. We are concerned with primarily 3 months, 10K, annual comprehensive, 10Q, quarterly, and 8K, which is like a press report that notifies the public about acquisitions, bankruptcy, liquidation, change in management, etc. Our solution breakdown has the following layers: scrapping, the financial aspect, the machine learning, the backend, and the front end. Our architecture is primarily divided into 3 modules: SaaS client, SaaS server, and data pod. Now let me walk you through the basic path of this. All of the data is under SEC Edgar base, and which we filed SEC filing. Scraping was a real challenge, and we had several rounds of trial and error, after which we noticed the US GAAP standard tags, and that really changed the game for us. HTML files have most of the numeric figures in tag, which contains the attribute nick. name that is defined by US GAAP standards for different reporting features. For example, the cash and cash equivalent have a value of the name attribute US dash cap semicolon cash and cash equivalents at carrying value. The application also uses Refinitiv Perm ID and the Alpha Vantage APIs. The former gives us information about name, address, website, phone number, fax number, holding type, and ticker of the company. Alpha Vantage gives us the monthly time series of the stock prices. Now, all of the data separately for 8K and for 10K and 10Q due to difference in the data type is methodically processed and systematically stored in our Firebase database, from where you can access it using Nest.js server. We send a query using GraphQL, which is sent by Apollo client, and we store this locally. We cache it for faster implementation, and we use all of this information to display different information in the front end, which will be discussed later. Scraping we did primarily via Python, Beautiful Soup, and regex. We mapped the found value to its features and used the regex formats defined in the application. SaaS metrics are highly important to assess the overall health. It essentially tells the investors about the various symptoms of the financial health of a company. KPIs are key performance indicators and one of the most critical metrics to track a company's performance. The various ratios that we had used were like return of equity, debt to equity ratio.
The slide hasn't changed.
It has changed for me. And we have also used different SaaS metrics and KPIs. And the main problem that we faced was there is no particular format for data consistency. SEC does not give us a format, and all the companies file according to the needs. So it's highly sporadic and they don't follow a uniform approach. We extracted data not only from text and tables, but also from plots, charts, images, and hyperlinks. Often the data is redundant. There are multiple subclasses of the same variable, which will confuse any user if they were going to go manually. And there were multiple integral values that were missing. And we had to take all of this into account to ensure that we do not skew the judgment in any way. We used ML to perform sentiment analysis over how the company has performed in the current fiscal year and predict an overall score. The SaaS metric ratios, as mentioned before,
Niyanti,
if these
the
ratios...
slides are not changing. Can we just represent it?
Okay.
Sorry for the inconvenience.
I'm at the ML integration slide. Is it visible now?
Yes, it is.
Yeah. So if these ratios lie within their ideal range, the company will perform well according to historical data. We did this and generated labels using binary encoding. The ratios were binary encoded with respect to their ideal range, generating an aggregate score as the final label, where 0 was the absolute bad and 1 was the absolute good when it comes to investment. We used regression, XGBoost regressor, to calculate the investability scores for the company. We use this to train a model on the SaaS matrix. It uses a boosting technique that works on the principle of ensemble, merge and take the best out of two more models. It usually gives quite accurate results compared to other regression models. We also validated our data with real world data. For example, let's consider the two companies, A10 and BSQR. The scores that we predicted showed that A10 is good and BSQR is bad, which was verified by the data we found on the internet by historical data of the two companies. To predict the company's sentiment for good, bad, or neutral, we used statistical methods to decide the range of the scores. For example, a good score would be something that scored above 35. We validated our results with actual historical data available, and then the table tabularized it to show our results. These are our scores when it comes to bad, neutral, and good in precision recall and F1 score, and you can find these in further details in our reports. We used all of this to calculate the investability score, which has been displayed not only year-wise, but also the latest year would be displayed here automatically. It provides an intuitive, to the point understanding of the user at a glance about the investability potential of any company. Talking about 8K analysis, here another hurdle that was faced was that the press release was often in a separate document and we had to take that hyperlink into account as well. We used the TextBlock library in Python to perform sentiment analysis on these sentences, and we obtained the subjectivity score of each sentence, which quantifies the amount of personal opinion and factual information contained in the text. To get a final set of sentences, we used a summarizer, which was Pegasus Financial Summarizer, which is a transformer-based model. The pre-trained model is available in the Transformers library by Hugging Face. We also clustered using 5 set of keywords depending on the occurrence of the keyword, and thus it was clustered. So this is the process. For financial sentiment analysis, we use Process AI, Finbot by Process AI. It's a transformer-based financial sentiment analysis model based on the very popular BERT, bidirectional encoder representations from transformers. From here on, Amog will guide you through the next part.
Thank you, Niyati. So the backend of a pipeline has been developed using Nest.js, which is a progressive backend framework built on top of Node.js and is used for creating scalable server-side applications. We have used GraphQL as the query language to query data from the server efficiently. And lastly, we have used Firebase as a database. The front end has been developed using React and Apollo client. The primary purpose of choosing React is that it is pretty fast, scalable, and straightforward. It offers a modular architecture which helps us make simple basic components. We have used Apollo client to make the fetching and caching of data seamless and efficient. Now, the problem statement specifically mentioned that a server should be able to respond to this request in a single API call, and GraphQL seemed to be the best possible solution to this. As an alternative to REST, GraphQL lets us make requests that pulls data from multiple data sources in a single API call, as you can see in the diagram shown. It basically acts as an abstraction layer between the client and the server, enabling the client to ask for data which is required, thus preventing over or under fetching. So this is the structure of a database. Company type is the outermost collection, which includes some company data such as address, ticker, company URL, etc., along with the actual data obtained from the company filings. The 10K and 10Q are sub-collections and include a list of all the filings and the corresponding data obtained from them. The raw data fields such as net income, gross profit, total equity, etc. are nested inside the features field as shown. And the schema of 8K sub-collection is slightly different. The various insights obtained from the 8K filings of the company have been divided into 5 different clusters, such as revenue, growth, etc. And we then perform sentiment analysis on the various sentences present in each of these clusters. The front end has a nice minimalistic landing page with a search bar to begin with. You can search for a company or multiple companies either by their names or by their CIK values in the drop-down menu. When you're done selecting a company, you're redirected to the main dashboard page where you can begin your analysis. So this is the window where we display a company's trends and performance over the years. You can switch to the chart section to look out for trends in the raw data directly obtained from the filings such as cash equivalents, net income, total equity, etc. You can also have a look at the analysis section, which displays a complete drill down of a company's performance along various metrics and ratios calculated from the raw data. The charts also have a zooming feature, which enables you to drill down along the time axis as well. We also provide a synchronized tooltip, as you can see, which basically lets you see all the parameters simultaneously at a point of time when you hover over it. Next is the comparison window, which gets displayed when you have selected 2 or more companies. As you can observe, we present a very intuitive UI with various calculated metrics and raw data features of different companies being displayed simultaneously on the same chart. You can also go ahead and download the plotted data in CSV, SVG, and PNG format. Next is the section where we display the breakdown of lengthy SEC filings obtained from the Edgar database into a structured and intuitive manner. You can navigate through various filings filed over the years and look for different sections, each of which deals with a different aspect of the company's reporting. Let us now talk about the scalability, sustainability, and the possible improvements we could have made in our application. So a pipeline is built on the dry technique using low data coupling and has high cohesion, making it highly adaptable to future updates with minimal changes in our code base. We have created a generalized data scraping module that requires only a company's CIK value to fetch all of its SEC filings and can utilize a novel text matching method to get required SAS metrics. We have also integrated our application with Docker, which makes DevOps quick and efficient. We can utilize Docker Swarm and Kubernetes to quickly deploy our models over highly scalable cloud networks. Talking about sustainability, a database uses NoSQL technology, that is Firebase, which is suitable for unstructured data, and the schema can be updated easily. However, we could also have opted for faster alternatives such as DynamoDB and MongoDB to scale our application if we were economically resourceful. Our backend uses GraphQL, which exposes a single endpoint and helps us overcome a lot of disadvantages of REST, as mentioned previously. We can thus update our schema and our server without the hassle of adding a new endpoint to serve the newly added data format. Finally, scope for improvements. Although we have tried our best to make the entire pipeline seamless and accurate, there's always some room for improvement. A few of them could be, we can automate the pipeline for inserting data of a new company. We need a cron job which gets triggered whenever a company files a filing or gets newly registered. and thus a data bot automatically adds it to a database. We can also look for alternative sources such as paid or unpaid APIs, which can help us get more accurate data and also bridge the gaps and inconsistencies present in the data obtained from the scraping of SEC filings. And finally, the front end can obviously be improved to make the understanding more intuitive for beginners and at the same time provide more in-depth detail to advanced investors. I would now like to invite Niyati back to show a brief demonstration of a web app. Thank you.
Okay, so I hope my screen is visible and you can see a landing page. So here we have a menu. Let's look at Adobe and we click on view charts and it takes us to the raw data charts of Adobe. You have net income, you have cash and cash equivalents. If you want to look at analysis, then the profit margin that goes into net income, we can see the debt to equity ratio. So total current liabilities is a factor, total stockholders equity is a factor, and you can see how it changes. We can look at SEC filings. Let's go in 10Q. Let's go in, suppose, this quarter. And I want to see condensed consolidated balance sheets unaudited. So it will take me to this tab and it will display the relevant details. Coming back, like I can go back and forth. We can look at 8K summary. These are neutral arguments that we have found in 8K summary, or we can look at the positive ones. I have 2 minutes remaining, correct?
No, one minute.
Okay, yeah. And if we were to add multiple companies, suppose we have Adobe, I add like Salesforce, or I add another company to it, like let's say Synopsys, you can see that the addition is instantaneous, both for the raw data and for the analysis that goes into this. It is very intuitive. If I remove these companies, and I just want to find the details for Adobe, I can go here and this will give us the details for Adobe. It will give us the investability score, and that summarizes our live demo. So technology has really empowered us to make sensible decisions when it comes to investing, and it is a due responsibility that we do better and we provide better for our community. That's all. Thank you, folks. This is Team 17.
Hi, this is Rajesh here. Thank you, Team 17.
Thank you, sir.
I was just wondering, like, did you get to any SaaS metrics? Like, I didn't see any SaaS metrics on your application. Like, let's say customer acquisition cost, or lifetime value of a customer.
So most of those SaaS metrics essentially depend on the number of customers involved, right? And those were not information that we could find uniformly in all the companies. Our option was to either resort to additional APIs that were either paid, or we were supposed to use guesstimates. We tried our best to compensate using theoretical knowledge, but because we would not have been able to provide it systematically for majority of the companies, we did not include the number of customers, which affects a lot of the SaaS metrics, like customer acquisition, as you mentioned.
Did you find them buried in the text portions of the filings? Like, some companies has it in the text portion of the filing.
Yes. So when analyzing the 8K data, we did find some statements related to customer. For example, there was a statement which said our customers grew by 200% over the last year. However, this was not quantified data, and it was displayed as a set of statements in the 8K results.
Okay. And if we go back to your architecture slide.
Yes, sir. Just a second. I'll just present my screen again. The architecture slide, correct? This one?
Yeah. So, so the SEC filings, again, I'm just trying to map this to what you showed me on the UI, where you showed list of filings, and when you clicked on something, it actually showed a small portion of the filing, right? So what are you actually storing in your database?
I would like to take this question. So, sir, we are storing a file called filing summary that is provided by SEC. The filing summary file link has all the links of individual tables in a HTML format. We store the link of this filing summary, and when in the front end we just fetch this data and link the individual balance sheets or individual tables through those links. So we actually don't store it in our database. We just store one single link that helps us get all the other uh, next links.
Got it. Okay. But if you have to run analysis on those metrics, like for example, the ones that you're showing on the UI,
No,
like the
yeah. So
graphs and
for the
charts.
analysis, this is different. But I am talking about the SEC filing section that we have in our UI, where we just break down the SEC filings into smaller tables that are provided. And the other aspect is, so this part is what I am talking about. The other part is the chart and analysis, for which we store some of the features. Niyati, can you just go to the database schema once? So yeah, here we store all the features of 10K 10Q in a JSON format. We store the values of all the features we are using in our UI to show, and the analysis part we calculate it using all these features, using the formulas of these features that are mentioned in our front end as well as in the data part.
Okay, what is the within SEC filings? What are you using to bring these metrics into your database?
So we are using. Okay, so in the SEC filings, we have a tag associated with each of these figures. That is a US GAAP standard tag. So suppose for any of these like cash and cash equivalent, so there is a tag US dash GAAP cash and cash equivalent. We just scrap that tag and the feature associated with it, and we store that in our database using this is all done in our databot module.
But did you run into any challenges? Like, for example, the usage of those tags is not consistent across companies.
No, actually, I would like to take this question. So basically, these tags are standardized US GAAP tags. So basically, for most of the features, we found that these tags are standard all across the filings.
But there is a taxonomy that is defined. Like, for
So
example,
yeah,
cash and
so we
cash
can give the
equivalent.
numbers. So we have around 190 companies data that is available in our website. That is following these standards of US GAAP, and so we could extract those things very easily using that tag. In some of the tags, there were multiple names. Maybe suppose the profit is called as gross profit as well as a profit, normal profit. So we could put some cases over there. So that was sorted like that.
Okay. So I see that 10K and 10Q, like the company features.
Yes, sir.
That has the values for at a quarterly level.
So yes, sir. So if you will notice the SEC filings, so the trend that every company follows is they publish 3 quarterly filings, three 10K, 3 10Q, and 1 10K filing. So they basically replace 1 quarter with their 10K filing. So because of that, we have to take it as a single schema, and that's how we stored it.
Okay, but how did you handle the numbers that are reported in 10K? Because what is reported in 10K is not per quarter; it's for the entire year.
No, sir. Some of the companies actually put it their quarterly last quarter data in the 10K and not the annual. Niyati, you
Okay.
can brief about.
Also, we have taken into cases. We have taken into account the cases. Many companies were instead of presenting quarter data, they were adding it, like they were adding the previous quarter's result to the next quarter itself, which allowed for seamless transition because then we have one quarter. In the second one, we have one quarter plus 2 quarter. In the third one, and so on. So the annual does not really show that much of a gap. It is consolidated that way. We have taken both the cases into account.
Okay. So my and like based on what I looked at, Q1, Q2, like the 10 Qs basically has that individual quarter data. Of course, they'll also have, last 6 months or last 9 months sort of data. But the purpose of each of the 10 Qs is the quarterly filings, right? And the 10K, it has the entire annual, like for the entire year. So let's say if you want to come up with the Q4 numbers, you have to add Q1, Q2, Q3 and subtract that from the 10K, the numbers that are reported in 10K. I was just wondering how you did that, because if you're storing the numbers at the quarterly level, if you're storing the numbers at quarterly level, how are you handling the numbers that are reported in 10K? And so that when you plot your graphs and charts, you have the numbers at the levels that you need. Okay, I don't have any other questions.
Yeah, hi, this is Sumit. Can you move towards the machine learning slide where you're classifying the companies as good or bad?
This one?
Yes,
Yeah.
yes. So how you guys are deciding like um like you're coming up with a number you come up with a threshold of 35, right? Below 35 you are considering this company as bad, and above 35 you're considering that as good. So how did you come up with this number, and
So
what are the dimensions that you are considering while coming up with this number?
Okay, I would like to take this question. So basically, using the current scores that we got for all the companies, we looked at the statistical distribution of the data, and based on that, we took the 25% value score and the 75% value score. So basically, if in the future, if there are more companies that come into play, then we can modify the thresholds according to the scores that these new companies get. And coming to your second question, could you please clarify what dimensions mean?
Yes, the parameters that are accumulating into the score, like you're getting the score eventually at the end, right? So what are the parameters that are like causing this score to be this much?
I answer this question, sir. So for generating a score, there is a certain procedure we have done. So we have used a financial ratio analysis technique. So this ratio analysis technique will help to tell about how a company is performing, and and by this the investor, this is a not a this is a finance knowledge, and by using this financial ratio analysis we generated their scores, and this will helps to these scores somehow tells the performance index, or the how the company is performing throughout the year. So this will helps to know that investor that this company has this kind of a scores, and then by using this and by this score it will reflect that how a company is performing throughout the year. And these scores comprises of parameters such as profit margins, gross margins, and so debt to equity ratios, return of equities, and other financial ratios too.
I'd like to add here that we also consider the ideal ranges for these ratio, like the working capital ratio for SaaS companies. If it is in the range of 1.5 to 2, that shows that the company is doing well. And thus applying ideal ranges to all the different ratios, we will able to categorize whether this falls below or within or above bad category, and we use that to encode our ratios.
And finally, we found that whatever methodologies we applied to find the score, these agreed with the real world data, and hence we were confident that we could proceed forward.
Yeah, thank you guys. That answers my question. Thanks.
Yeah.
If the questions from all the judges are over, Team 17 can now stop their presentation.
All right. Thank you, everyone. It was a pleasure.
It's a small announcement to all the judges. So, Team 19 won't be presenting today because they are traveling. So, next team we have is Team 13. Team 13 would be the last presenters. So, I'll request Team 13 members to kindly raise their hands.
Hello. Is my voice audible?
Yes.
Hello.
Yes. The team can now present the PPT.
Yes, I'm presenting.
Hello. Hello.
Yes, you are audible.
Is my screen visible?
Yes. You can now begin your presentation.
Yes.
Good evening. We are Team 13. First, we would like to explain our interpretation of problem statement. The problem statement was to make a dashboard of SEC filings of all US listed SaaS firms for all accessible years, capable of examining those companies for all available years of data. The Security and Exchange Commission is a US government oversight agency responsible for regulating the securities market and protecting investors. And EDGAR is an online system created by the SEC for corporate filings. Then there are some of the main SEC filings. Uh, Form 10K is filled by all public US companies. It presents annual financial picture of a company detailing its revenue, assets, liabilities, etc. Form 10Q comprises of financial performance submitted quarterly, which contains financial statements, management discussion and analysis, disclosures, and internal controls of that particular quarter. Form 8K announces event relevant to shareholders. Companies use 8K as needed, but it is valuable source of complete and unfiltered information for investors and researchers.
So over to the solution which we are proposing. For this problem statement, we have come up with an interactive and intuitive website which will enable the user to search for a company, and the website will return a dashboard which shows the financial analytics of the company. So the features of our website is we have made an intuitive dashboard. Also, we have included a search bar which comes up with suggestions that enable that is enabled on typing. So next, for the ML part, we needed data. So we made use of a single call API from the SMJS library to get all the filing data and use it for ML. Furthermore, our website has various graphs and plots that shows various analytical features like the liabilities, shares, and assets. And for the ML, we have used sentiment analysis and predicted some scores. Also, our website provides the option for the users to download the assets and shares data over the past few years. Finally, our website has a tabular format of the 10K links of the previous year, which in turn leads the user to a new page where the form is listed in sections. So the main task is divided into WebD and ML modeling. So WebD includes making graphs and UI UX, whereas our ML models does sentiment analysis and returns scores like positivity, negativity, ridiculous, polarity, and many other tags.
Am I audible?
Yes.
Okay. So first let's talk about the web development part. The tech stack that we used includes Django and Django templates for the backend and frontend respectively, SQLite 3 as the database, and Amazon AWS for deploying the website. We used Django because it allowed us to rapidly develop the website in a short amount of time, and it is also scalable. It also comes with built-in support for SQL databases, and the default database is SQLite 3, which is very lightweight and easy to use. And for deployment, we used AWS because we were already familiar with it and its features, so we saved some learning time there. Our SQLite database consists of a table with 3 columns, which are CIK, ticker, and company names. So this is the UI of a search bar, which we have created according to the guidelines. When you click on the search bar, it will show you the list of all the companies that we have in our database. You can also start typing the name of a company in the search box, and it will show you the relevant recommendations based on what you have typed. When you click on the search button, it will take you to another page consisting of the details of the queried company. On the company details page, you'll see that there are some form links. These are the 10K forms of that particular company over the past few years. And these links were scraped from the Edgar website. For web scraping, we use Selenium WebDriver in Python, which makes it easy to automate visiting a web page and downloading multiple files quickly. On the right hand side of the page, you can see the option to download the shares and assets data of the company in .csv format. The first chart depicts the annual shares of the company, and this information is extracted from the 10K forms. You can also see the percentage change in the shares of the company from that of the last year. The second chart depicts the company's annual liabilities. This information is also extracted from the 10K forms. The third chart depicts the scores obtained by doing sentiment analysis of the 10K forms of the last 2 years. All of these charts are being created in real time using chartist.js JavaScript library.
So here comes the ML part. We utilize an NLP-oriented approach in which we specified a specialized word list to score the actual text of these filings for several characteristics like risk, uncertainty, readability, litigiousness, sentiment, and provided accessible numbers to signify these traits. For this, we used an Amazon Web-based services environment, short for AWS. AWS provides direct API called SMJS Industry Client Library, stands for SageMaker Jumpstart Client Library. The API requires machine to be used and volume size to be specified. It also needs the input of tickers or CRK codes for the companies to be covered, as well as the three form types 10K, 10Q, and 8K to retrieve along with date range as well as the file name where the retrieved files to be stored. For an ML model to be trained, the foremost requirement is of data to be fed as input to the model. So on that note, the files were downloaded from SEC's Edgar website, all the while complying with the terms and conditions. The retrieve functionality is integrated in an SageMaker processing container, and through the API call, we retrieve 10K, 10Q, and 8K filings. The extracted data frame is then returned to Amazon S3 storage as a CSV file.
So now we will talk about the process which we have gone through. Our main task was to retrieve the data, extract it, make it into a readable format, and then applying the NLP model to it so that we can do the sentiment analysis. For all this, we used many algorithms mentioned before, packages, libraries which were packaged into Amazon SageMaker package. SageMaker provides functions and libraries that are useful for financial analysis. Using this, our all effort was reduced to just a single API call, which was also requested in the problem statement. We extracted the company's list along with its CIK and tickers with date range mentioned and form type. We stored it as a CSV file in the S3 bucket. After that, we we filtered out the 10K dataset and made a new data frame having a list of companies of form type 10K. Now we will look into the how the ML part has been worked out. We all have all the financial text which was retrieved from the forms and was stored in a CSV file. After that, we scored it using NLP model present in the SageMaker Jumpstart package called NLP Scholar. It provides us 11 NLP scores mentioned here in the slides. These scores were added as new columns into the data frame. Talking with the perspective of the sentiment score of each of the companies, it was calculated on the basis of Vader library, in which good sentiment has a score of 0.05 or greater. Neutral has a sentiment of minus 0.05 to 0.05, and bad has a sentiment less than minus 0.05. We calculated sentiment scores, but we were unable to classify them. To summarize groups of paragraphs into single summary, we used Hugging Face Summarizer, and the summary of each company was added in a separate column. The final output was exported as a CSV file, and then we used it in the website. Thank you. We are concluding our presentation. We would like to present the live demo of our deployed website. Can you please allow us for that?
Yes, it's under your presentation time, so you can present your demo.
So this is our home screen. So the user is allowed to search for any company. And our website features over 193 companies. So here it shows the shares, annual shares data. So it has been extracted using the 10K forms, and it shows the change over the previous year also. Then the user is given the option to download the assets and shares data, which gets downloaded in a CSV file. And this data consists of previous year data, assets over the past few years annually. And here the user is also provided with the links where the section-wise distribution of the 10K form is displayed. Furthermore, the next graph shows about the liabilities, and also then we are displaying the ML analysis, which the ML model returned to us. So we can see that company is what's the score, positive score, negative score, certainty, risk, safe, and other parameters. So this was the demo of our website. Thank you. So we are open to questions now.
Thanks for the presentation. Can we do a little bit deep dive into how that SaaS company performance works? Like I know you had few parameters there.
Yes. So basically, we use the SageMakers and in AWS notebook, and there is a library called SMJS Industry. So there is a word list. So there is a library specifically for Edgar filings. So since we are trying to make it, since it makes the work easier for us, as we are able to retrieve the entire data through a single API, we use that particular library. So how it works is it has a word list for positive and each of these categories. So it does sentiment analysis on that, and more about how the sentiment analysis work, it will be explained by my teammate Aditya.
So, as Joel has said, we have used SageMaker Jumpstart library. In that library, it provides 11 NLP scores. Uh, uh, to extract all the data, we used SEC Edgar extractor that is also provided in the SEC Jumpstart library. Um, the library just uses Vader basics, and from that it calculates the sentiments of each of the companies in the range of minus 0.1 to 0.1, and the sentiments are tabularized in the each of the data set of the company.
Excuse me, sir. Does this answer your query?
Yeah, but I was just wondering, like, how is using that library gives us SaaS performance? Because
Um,
we're looking for certain SaaS metrics, right?
Yes, sir. Like due to our constraints, we weren't able to get much metrics about the like the CAL and other values. Specific metrics we weren't able to retrieve. So we just did sentiment analysis on the 10K forms, and from that we are just scoring it like it's how positive or negative scores we are just determining. But we weren't able to get specific metrics as of that due to our
Okay. Yeah.
constraints.
Okay. Okay. Thank you.
So is the architecture of your product is a scalable architecture? If yes, then can you please explain?
Yes, sir. So basically, the backend is on Django. It is hosted on AWS, so EC2 instance.
Okay.
So the architecture, how we have planned it is, front end is also in Django. It's like basically in Django templates, HTML, CSS, and JS. So since everything is in Django, each we have a model in it, the SQLite database, which basically contains the companies and the CIKs and the tickers. So these three things are there. So whenever a user searches, so before all of this, we created a pre-processed data CSV file which contains all the company's 10K filings as test format data frame. So that thing is stored in AWS again in the same bucket as a bucket. In the bucket it's stored. So basically we retrieve that information and we use the data from that for the all of the features. And in this, the real-time data is used in the plotting these graphs, shares and liabilities. So SEC provides a API for that. So we are using it to display that.
So by
So,
any chance, do you have the architecture handy, like the complete architecture on the AWS?
yes, everything is on the AWS,
No.
but we didn't make a flowchart or
Okay.
anything like that now.
Okay. And why did you choose the SQL database over the NoSQL? As NoSQL can also be a good fit here for the unstructured data and all that. So why did you choose the SQL database here?
Yes, like it was like this is much. We felt ki the here the main use of the database was to store the company's CIK and stuff, and that's the thing we are doing by already pre-processed data. So we felt ki using SQLite would be better as it is faster. It has faster loading time and it is pretty lightweight. So we didn't plan it for much heavy usage in the database side. So it just stores the company's CIK and we are retrieving it from the CSV files which are obtained in the MLs and API. So we thought ki we'll go with SQL in this sense. And
Okay.
it was, to be honest, the comfortable. I mean, we are comfortable with SQLite.
Okay. And can you also talk about the future updates to this particular product? Like what are the three major future updates you are thinking
Yes,
on
sir.
the current
The
version, right?
Yes, sir. In the first major feature we are planning to add is to provide the user with a comparison page where he or she can compare the different with over various companies, and we are yet to extract. We plan to display some specific metrics also about the customer intake and stuff, which we weren't able to complete on time. So these two are the main, and the third one would be provide the user with the option to add the companies to watch list. Suppose if I'm interested in a particular company, I can keep tabs on it in the watch list or favorites. We are planning to provide that list. So in that sense, if any sudden spike or change in that company's liabilities or shares anything, the user gets intimated. So and we will if we weren't able to retrieve the metrics. So if after that feature, we would also have the investability score and how good is the company is the company worthy of investment. I mean, worthy in the sense, is it profitable or not? So if we have that score, the watch list feature would be very useful. These three are the main features we are planning to add
Okay.
in future.
Thank you.
Also, you requested us to show the architecture. I've just logged into our AWS. I can show the SageMaker. SageMaker. Can you allow us to present?
Yeah, please go ahead.
I have no presenting access.
That I think Avanti can provide you.
Sure. So this is our bucket. In this, we have two objects: SCC analyzer, and then the company list. We have extracted the companies along with its GIK and CIK and tickers. In this, so this is our SageMaker.
Okay, thanks for this, but I was more interested in, just to see the overall, the complete solution architecture end to end, but that's fine.
Okay. No.
Thank you.
I think we don't have any other questions.
Yeah, if no other judges any query, Team 13 can stop their presentation. And yeah, this was the last presentation for today. So hence we complete 17 total presentations, including yesterday's and today's. So thank you all the participating teams, and thank you all the judges for taking initiative to like evaluate and devote this much time. I'm very thankful to every judge and all the participants. So yeah, we'll just end the session here, and all the teams will be getting their scores shortly. So yeah, this marks the end of the session. Thank you all.
Thank you.
Thank you so much. Thank you. Thanks everyone. Thanks for organizing this.